In the next lecture of jigs and fixture, today we are going to cover clamping and clamping devices. Also, if possible, we will try to start with a new module. We'll start with our point clamping and clamping devices. Clamping and clamping devices includes requirement of clamping system. So, as we know that when 3 to 1 location system, that is 3 pin, 2 pin and 1 pin location system we have used, there 9 degrees of freedom can be restricted and remaining 3 degrees of freedom has to be restricted by clamping system. Now clamping devices are used to hold the workpiece securely against the locators throughout the machining operations. To accomplish this, clamps or clamping system should have to satisfy following conditions. First, it should be strong enough to withstand cutting forces produced during machining operations. Clamping system must not damage the workpiece. It should be simple to use so that semi-skilled operator can operate it. It should be foolproof. It should allow minimum loading and unloading time. To design a clamping system properly, a tool designer must know about basic clamping principles and clamping devices. When we talk about the position of clamps, we see position of clamps should be such that it should contact the workpiece at its most rigid point. It should avoid any damage to the workpiece. It should avoid bending of the workpiece. It should not interfere with the machining operations. It should not obstruct workpiece loading and unloading path. It should be arranged directly above the supporting points. In case of brittle workpieces, fiber pads should be provided between clamp and workpiece. Clamping pressure provided by the clamp should be directly parallel to the cutting forces but should not be directed towards cutting operations. Now when we talk about the clamping force, please note down the following points about clamping force. Clamping force is required to hold the workpiece against the locators, which prevents movement of the workpiece while machining operations. Amount of clamping force is generally determined by calculating overall tool forces experienced by workpiece and position of workpiece with respect to tool. Clamping force should only be enough to restrict the part movement. Excessive application of clamping force may distort the workpiece. When we talk about types of clamps, they are strap clamp, screw clamp, swing clamp, hook clamps, wedge clamps and quick acting clamps. According to type of operation, shape and size of workpiece, jig and fixture being used, suitable type of clamp are selected. Strap clamps or lever type of clamps, I have given you the diagram, but the points to note are, they are more simple and easy to use clamps. These are made of rectangular plates and acts like a lever. Clamping force is applied by a hexagonal nut. One end of the strap clamp is pressed against the workpiece and other end is supported by heel or heel pin. The clamping end of the strap clamp is made curved and pressure face of the heel pin is made spherical so that any variation in the workpiece size can be compensated. Strap clamps can be grouped into 3 classes as first class lever, second class lever and third class lever. First class lever has a fulcrum between the workpiece and fasteners for efforts. Second class lever has a workpiece location in between fulcrum and effort, and in third class lever effort is placed in between workpiece and fulcrum. Strap clamps can be operated manually or by power driven devices, whereas manually operated strap clamps consist of nuts, knobs and cams, whereas power operated clamps consist of pneumatic or hydraulic arrangements. Various clamping arrangements I have given you on the mail, please go through that. Next clamp that we are going to discuss is a screw clamp. Now as the name indicates, screw clamps has unlimited applications in jigs and fixtures as they are easily available at a low cost. These clamps are simple and easy to operate. The only limitation of these clamps is its slower operating speed. Next is a swing clamp. Swing clamp consists of screw clamp with a swinging arm. Therefore, clamping force is generated by the screw, and because of swinging arm, time taken for clamping is less. Hook clamp, they are similar to swing clamps, but size of hook clamps are smaller. Therefore, they are used in tight place where other types of clamps are inconvenient. Wedge clamp, as the name indicates, wedge clamps inclined plane is used to force the workpiece against a fixed top. The wedge has 1 degree to 4 degree angle and it is self-holding. Vertical clamping force is created by horizontal movement of wedge. When we talk about quick acting clamps, they are considered as following types. First, as a quick action nuts. Second, cam operated clamps, swing washer and C washer clamps, toggle operated clamps and bayonet clamps. When quick action nuts are to be used, they are to be used when it is required to remove the nut each time. It consists of plain hole and threaded hole. The plain hole is machined at an angle of 3 degree to 7 degree and the diameter of plain hole is larger than the diameter of the stud. Because of this arrangement, time required to operate this nut is minimized. Cam operated clamps. These clamps provides simply, easy and quick way to clamp the workpiece securely. It uses can action to apply the clamping forces. C washer and swing washers. Now these clamps allows unloading of the workpiece without removing the nut. They are nothing but the strap clamps having open slot, and the open slot permits removal of the washer after slight loosening of the nut. Now the size of hexagonal nut should be less than that of the bore of the workpiece so that it will not interface during the workpiece loading and unloading. So this was the condition used for swing washer or C washer clamp. Toggle operated clamps. Small fork movement produce large clamp movement. They can move completely free of the workpiece and these clamps operate on a system of levers and pivots. Bayonet clamp. It has a partially threaded cylindrical clamp. A part of the groove in bayonet is straight. Movement of bayonet is guided by a spherical ended screw mating with the groove in bayonet. It can be pulled back straight axially through the straight slot to provide enough clearance during workpiece loading and unloading. Following steps are followed to clamp the workpiece by means of a bayonet clamp. Pushing the bayonet forward through the straight groove so that clamping force or clamp touches the workpiece. Turning the bayonet clockwise at the end of straight portion, inclined groove in the bayonet acts like a part of thread. 1 degree to 7 degree of helix angle is provided to the inclined part. Because of this, clamp does not get loose due to vibrations. Other clamping devices that are generally used are multiple clamping devices like double clamping, equalizers, stacking, and power clamping devices includes pneumatic clamping, hydraulic clamping, vacuum clamping, and magnetic clamping. When we talk about multiple clamping devices, in double clamping, the method is used when it is required to clamp two workpieces with the same variation by a single strap clamp. Equalizer allows variation in the workpiece sizes. It is pivoted around a pin. Even number of workpieces can be clamped by an equalizer. Stacking. In the stacking arrangement, number of workpieces are stacked together and whole stack is clamped by a single clamp. And when we talk about the power clamping devices, the first point that we have to note is it has a limited clamping pressure, the operating time is more, chances of operator fatigue, clamping pressure varies from one workpiece to other. Now these all were the limitations of manual clamping, and in order to overcome these limitations, we are going to see pressure clamping, that is power clamping. The first is pneumatic clamping. Pneumatic clamping and hydraulic clamping devices are grouped under fluid power clamping. Generally, these devices require less initial investment but has following limitations as it provides low clamping pressure as compared to hydraulic devices, and they are vulnerable to variation in the load as they move. The leakage problem may be observed. In hydraulic clamping, as oil is incompressible, it can be used to exert larger clamping pressure. Oil is recirculated in this system through reservoirs. Speed of the hydraulic device is generally slow as compared to pneumatic devices. Apart from this, it eliminates other limitations of pneumatic systems. And vacuum clamping. With the help of vacuum, thin flat sheets can be clamped securely onto the jig or fixture base without observing any distortion in the sheets, as it provides light clamping pressure. Magnetic clamping. Permanent magnets or electromagnets can be used to clamp the metal workpiece to the base. Permanent magnets are moved under the table so that magnetic flux can be passed through the workpiece, which holds the workpiece magnetically. Now to release the workpiece, permanent magnets are moved under non-magnetic material, that is, it blocks magnetic flux and deactivate magnetic actions. Now component distortion under clamping and cutting forces is the point that we have to discuss very seriously. Excessive clamping force may distort workpieces. And examples of workpiece distortion can happen in the convex structure or concave structure. Now this scenario happens because of wrong locating and clamping system, selection of wrong cutting tools, wrong procedures, or wrong design of jig and fixture itself. Now these situations can be eliminated by following basic design principles of jigs and fixture. It is the duty of tool designer to verify all aspects of design. When we consider materials used for different clamping devices in the jigs and fixture, and we have to understand the recommended hardness for the devices. Various materials are available to manufacture clamping devices of jigs and fixture. Because of continuous use, wear tear of clamping devices may happen, so these devices are generally hardened to resist wear and tear. Some of the commonly used materials for clamping devices with their hardness are high speed steel, that is HSS. It contains 18 to 22% tungsten, which provide toughness and strength. It contains 4.3% chromium. It gives better hardenability, and 1% vanadium, which gives impact resistance and red hardness. Therefore, it can be oil hardened to RC65, that is grade of 65. Die steel. It is also called as HCSC, that is high carbon, ranging from 1.5 to 2.3, high chromium, 12% as a cold working steel. In case of high temperature application, hot die steels with lesser carbon, that is 0.35%, and chromium with percentage of 5, alloy with molybdenum Mb 1% and vanadium 0.3 to 1% is used. High tensile steel is the next category, which can be grouped in two categories as medium carbon steel with 0.45 to 0.65% carbon and alloy steels, that is En24. And high tensile steel can be hardened up to Rc40. Mild steel, it is most widely used material as carbon percentage in mild steel is less than 0.3%. In case of light duty application, use of mild steel is preferred as its cost is very less. Carbon steel contains 0.85 to 1.18% carbon, as it can be oil hardened to Rc63. In case of heavy wear situation, carbon steels can be used. Spring steel or college steel contains 1% carbon and 0.5% manganese, and it can be tempered to Rc47. Oil hardening non-shrinking tool steel, that is OHNS, contains 0.9 to 1.1% carbon, 0.5 to 2% tungsten, and can be hardened to Rc62. And last material that we have to discuss is phosphor bronze. It contains 94.8% copper, 5% tin, and 0.2% phosphorus, as it is widely used for replaceable nuts. It provides better corrosion resistance. So, dear friends, with this discussion and with this briefing, we have completed module number 2 from our syllabus. So, in the next lecture, we will start with construction of drill jig, and we will study the introduction, selection of location, supporting and clamping points, cutting tool and means of guiding and supporting jigs, various types of jig bushes, commonly used drill jigs, case study on design of drill jigs. So, please go through the above videos and prepare for module number 1 and 2. Till then, thank you.